Today we are going to see the classification of engineering materials. Engineering materials form the backbone of modern technology and industry. Their properties, availability, and performance determine their use in construction, manufacturing, transportation, aerospace, electronics, and countless other fields. Broadly, engineering materials can be classified into four major groups. First is metals and alloys. Second is ceramics and glasses. Third is polymers. And fourth is composites. Each group possesses unique characteristics that make it suitable for a particular engineering applications. So first is metals and alloys. Metals are materials characterized by high electrical and thermal conductivity, metallic bonding, ductility, and malleability. They are usually crystalline in structure and widely used in engineering for their strength and toughness. Properties of metals: high strength and toughness, good electrical and thermal conductivity, ductile and malleable, that is, can be drawn into wires and hammered into sheets. Then metallic clusters. Some examples are iron, aluminium, copper, manganese, zinc, nickel, and titanium. Then alloy. Alloy is a mixture of two or more elements where at least one is a metal. Alloying improves mechanical, thermal, and chemical properties of metals. Some examples are steel is the alloy of iron and carbon used in construction, automobiles, and machinery. Then copper and zinc forms brass used in plumbing or and electrical fittings. Then copper and tin forms bronze used in bearings, coins, sculptures. Then iron, chromium and nickel form stainless steels. It is a corrosion resistant applications. Then titanium alloys, aerospace, biomedical implants. Application: structural materials, automotive industry, tools, electrical wires, machinery parts, aircraft frames, and energy equipments. Now, second type is ceramics and glasses. Ceramics are inorganic, non-metallic materials made by heating natural materials like clay, silica, and alumina at high temperatures. They are usually crystalline in structure. Then, properties of ceramics: hard and brittle, high compressive strength, high melting point, good electrical and thermal insulators, resistant to corrosion and wear. Some examples are alumina, silicon carbide, zirconia, and ferrites. Applications: cutting tools, bearing, spark plugs, refractory linings, tiles, aerospace thermal sheets, biomedical implants. Then glasses. Glasses are non-crystalline, that is amorphous, inorganic solids obtained by cooling molten materials rapidly. Then properties of glasses: transparent, brittle, excellent electrical insulation, poor thermal shock resistance. Some examples are soda lime glass, borosilicate glass, silica glass, optical glasses. Then applications: for windows, containers, optical fibers, lenses, laboratory equipments. Then third type is polymers. Polymers are long chain organic compounds composed of repeating units, that is monomers. They can be natural or synthetic. Properties of polymers: lightweight and low density, corrosion resistance, electrically insulating, can be flexible or rigid, low strength compared to metals but easily processable. Types of polymers: thermoplastic polymers, soften on heating and can be remolded. Examples: polyethylene, polypropylene, polyvinyl chloride, polystyrene. The second is thermosetting plastics, harden permanently after heating, cannot be remolded. Examples: bakelite, epoxy resins, ultraformaldehyde. Then third type of polymers is elastomers, highly elastic materials. Examples: natural rubber, neoprene, silicone rubber. Then applications: packaging, pipes, electrical insulation, automobile parts, textiles, adhesive, coatings, medical devices. Then fourth type is composites. Composites are engineering materials made by combining two or more different materials to achieve superior properties not present in the individual components. Typically, they consist of a matrix, metal, polymers, or ceramics, reinforced with fibers or particles. The properties of composites: high strength to weight ratio. Tolerable properties are depending on combination: high stiffness and toughness, corrosion and wear resistance. Types of composites: polymer matrix composites, epoxy plus glass fibers, fiberglass, carbon fiber reinforced plastics. Metal matrix composites, aluminium plus silicon carbide and titanium plus boron fibers. Ceramic matrix composites, silicon carbide plus fibers and aluminium reinforced ceramics. Applications: aerospace, aircraft, fuselages, turbine blades, then automotive, sport equipment like tennis rackets, bicycles, then construction, biomedical prosthetics. Conclusion: the classification of engineering materials into metals and alloys, ceramics and glasses, polymers and composites provides engineers with a framework to select suitable materials for diverse applications. Metals and alloys, high strength and toughness, widely used in structural and mechanical systems. Ceramics and glasses, excellent thermal resistance and insulating properties, used in high temperature and electrical applications. Then polymers, lightweight, versatile, corrosion resistance, ideal for packaging and consumer goods. Then composites, tailored material with superior performance, essential for aerospace, defense and advanced technologies. Understanding their properties and application ensure that engineers can design systems that are efficient, safe, durable and economical. So why we are study the types or the classification of materials, because their properties help and applications for engineers can be design system or equipment or jobs that can be efficient, safe, durable and economical. So that's why the classification of material is very useful. Now here you can see that the references for classification of engineering materials.